Hello everyone, this is Siddiqur Rahman and welcome to the third lecture of the third week. So let's start. By the end of this lecture, you guys will be able to know about Boolean algebra as well as the laws of Boolean algebra. This slide represents the overall scenario of this lecture. You guys will learn from this lecture Boolean algebra, laws of Boolean algebra such as Associative Law, Distributive Law, Commutative Law, Absorption Law. So start with the overview of Boolean algebra. Boolean algebra is the mathematics we use to analyze digital gates and circuits. Switching algebra is also known as Boolean algebra. It is used to analyze digital gates and circuits. It is logic to perform mathematical operation on binary numbers, that is on 0 as well as 1. Boolean algebra contains basic operators like AND, OR, and NOT, etc. Operations are represented by dot for AND and plus sign for OR. We already know that. Operations can be performed on variables which are represented using capital letter such as A and B, etc. Boolean algebra uses a set of laws and rules to define the operation of a digital logic circuit as well as the logic symbols 0 and 1 being used to represent a digital input or output. We can also use them as constants for a permanently open or closed circuit or contact respectively. So let's move into the next slide. From this slide we may know some of the laws of Boolean algebra. So let's start. The main aim of any logic design is to simplify the logic as much as possible so that the final implementation will become easy, or fabrication. Final implementation means fabrication. Fabrication means to use for commercial purpose. In order to simplify the logic, the Boolean equations and expressions representing that logic must be simplified. So to simplify the Boolean equations and expression, there are some laws and theorems proposed. Using these laws and theorems, it becomes very easy to simplify or reduce the logical complexities of any Boolean expression or function. The basic rules and laws of Boolean algebraic system are known as laws of Boolean algebra. Some of the basic laws of the Boolean algebra are as follows, such as Associative Law, Distributive Law, Commutative Law, Absorption Law, Consensus Law. So let's start with the Associative Law. Well, first we need to know the statement of associative law, and there are two law. The associative, sorry, I repeat again, the associative law consists of two law. One is associative law of addition and another one is associative law of multiplication. So let's start with the statement of associated law of addition, which states that OR-ing more than two variables, which is mathematical addition operation performed on variables, will return the same value irrespective of the grouping of variables in an equation. It involves in swapping of variables in groups. The associative law using OR operator can be written as A plus inside of the parenthesis B plus C is equals to inside of the parenthesis A plus B outside of the parenthesis plus C. Now we may learn another law of associative, which is multiplication of associative law, and let's start with the statement of the multiplication of associative law, which states that AND-ing more than two variables, which is Mathematical multiplication operation performed on variables will return the same value irrespective of the grouping of variables in an equation. The associative law using AND operator can be written as A and inside of the parenthesis B and C is equals to inside of the parenthesis A and B, outside of the parenthesis and C. From this slide we may learn about the distributive law. So let's start. This is the most used and most important law in Boolean algebra. Remember this sentence, which involves in two operators. One is and another one is or. So let's start with the statement of let's start with the first statement of this law, which is the multiplication of two variables and adding the result with a variable will result in same value as multiplication of addition of the variable with individual variables. In other words, adding two variables and or in the result with another variable is equal to and of or in of the variable with the two individual variables. The distributive law can be written as A or inside of the parenthesis B and C is equals to inside of the first parenthesis A or B, after that inside of the second parenthesis A or C. This is called or distributes over and. So let's move into the next statement, which states that the addition of two variables and multiplying the result will a variable will result in same value as addition of multiplication of the variable with individual variables. In other words, or in two variables and in the result with another variables is equal to or of and in of the variable with the two individual variables. The distributive law can be written as A and inside of the parenthesis B or C is equals to inside of the first parenthesis A and B, after that or, then again inside of the second parenthesis A or C. This statement or this is called and distributes over or. Now from this slide we may learn about the commutative law. So let's start with the statement which states that the inner changing of the order of operands in a Boolean equation does not change its result. The commutative law can be written as A or B is equals to B or A, and which is using OR operator, and second one is A and B is equals to B and A, which is used AND operator. This law is also has more priority in Boolean algebra. From this slide we may learn the law of absorption. So let's start. Absorption law involves in linking of a pair of binary operations. The absorption law can be written as A or A and B is equals to A and inside of the parenthesis A or B is equals to A or not A and B is equals to A or B. A and inside of the parenthesis not A or B is equals to A and B. Third and fourth laws are called as redundancy law. Remember these things. In the next lecture you guys will learn about De Morgan's theorem. That's all for this lecture. Thank you guys for your attention. See you guys in the next lecture. Thank you.